we've talked a lot about basically almost all of the main data types you'll come across in JavaScript. So we've talked about the primitives, right? The numbers, the strings, the booleans, etc. Those hopefully by now you're very comfortable with. We did 2 days on arrays, and then we spent yesterday on objects. The last one that we really kind of want to talk about a little bit more is functions. And we're going to talk about functions in conjunction with objects because usually speaking, functions don't kind of exist independently, if you will. So the way that we write problems here is like, for the workshop problem, it's like write me a function that does this, and we just kind of write it in a blank space. That very rarely happens in real code. Usually functions are values of other objects, right? And so when we look at today's method, or we look at today's lesson on methods, we'll kind of see ways in which how we create more functions, probably realistically in a real world environment. So what is a method? Honestly, methods are just functions. Methods have more of a linguistic distinction from functions, but performance-wise, in terms of how we use them, I guess pun intended this time, functionally speaking, they are just functions. And so the reason why we distinguish them is because you know how when we talk about array.indexOf, right? Notice how we say array.indexOf. And without that array, we really can't call indexOf. And it's because indexOf doesn't exist by itself. Whereas if I write a brand new function for myself called function David, and I pass in a number and it gives me back the number plus 5, that function exists in of itself. So let me just do a quick and dirty example here, right? If I do so let arr equal an array, right? If I do function David and all it does is console.log out hi, right? I can call David and it totally works, right? I print out hi. But if I want to call .index, so let's say this has a number, this has 3 numbers, 5, 6, and 7, right? If I want to do array.indexOf, I want to say when the 5 is, I get back index 0 because this 0 is the first element in the array, right? Notice how even though indexOf and even though David in those cases are both functions, what I can't do is I can't just call indexOf 5, or at least, forget this error, but basically this is saying, hey, you can't call this function kind of by itself, right? And so this is the distinction between a method and a function, in that a method usually, so indexOf we consider to be a method of ARR of an array. So when we do arr.indexOf here, indexOf is a method because it's a function, yes, but it belongs to an object. So in order for us to call this function, we must first acknowledge the object that it's kind of attached to, right? This data function has no attachment; it's just there. So I can call it, anywhere I want by itself. And in fact, because it's not attached to an object, I can't say arr.david, because then it'll say, oh great, arr must have a David function somewhere in there, right? And it'll look for it and I can't find it, and that will throw me in error. So this is kind of just colloquially the main distinction between a function and a method. Hubert?
So are you saying that because ARR it's an array, but it's also an object, so then it's an array object? That means that
Yep.
indexOf is a method on the array object. That's where
Yes. So array indexOf. So yeah, this is probably. So basically, so when we look at the documentation for indexOf, this is something that I'm not going to spend too much time on in this class, just because you'll kind of learn more about it in the full-time curriculum. But in this case, we have array.protype.indexOf, and what this basically says is anything that is made off of the capital A array class, aka any array that we ever make, is going to inherit from this array class and all the functions within it, because it's a prototype. And so therefore, this means any array that we make, as long as it's built off of this capital array class, it will have the indexOf function kind of as a property, as a method. And also, I guess, just to be clear here, methods are functions. Property is like values. Anything else, it's like a method that's not a function. Right? So that's kind of the distinction there.
That's not a function.
Well, so if I say Like if I make, great example, array.length. Length is not a function, right? It's a number.
Oh.
So saying like my length is 6, right? So that's called the length property of the array, not the length method of the array, because it's not a function. You don't call it.
That's a great example.
Yeah.
Very good, thanks.
Yep.
So can we add methods to the array object?
Totally. Yeah. So you're totally welcome to. Generally speaking, people don't add it to pre-existing classes like arrays because those are built into JavaScript. What you do is you build your own class that's like almost like a copy of array, and then you add it to your own classes. But all the time, people definitely add it all the time, and we'll see today in today's lecture cases in which people add things to objects. Okay. Sorry, one more question.
Wait,
Hello?
method versus property thing?
Yep.
The array.indexOf is going to give you a number as well because it's going to tell you where it is in the index.
Yep. So if I was to call AR.length here, let's just console.log out both of these. Okay, great. So when I call it, notice how array.indexOf, I have these open and close parentheses, which means I'm invoking a function. That means indexOf is a function, so it's a method, right? Length, there's no invocation. It's just a value. It's just like a thing, right? I'm not asking you to do anything. I'm just saying you are, like, what is your length? It's just going to give me back a static value. So that's a difference between a property and a method. Cool. Any other questions? I see. All right, cool. So yeah, so I mean, and this is one of the main reasons why we know when we talk about objects or arrays, we teach you all these methods, right? Is because they come pre-built into JavaScript. They're super nice, very helpful, and usually they are things that you just kind of take for granted. That we all take for granted, right? Like whenever I use an array, I take for granted it's going to have a function called indexOf. It's going to have a property called length. It's going to have an object's going to have all these different properties too, right? So these are just kind of like nice things to know because they come kind of built in with the ecosystem. So yeah, so when I do country.indexOf Brazil, indexOf, once again, it's a method of countries because countries is an array, and all arrays come built in JavaScript with a bunch of functions, with a bunch of methods that do certain things for me already. So if I ever use an array, I never need to create my own indexOf function unless I want to overwrite the old version with my own custom version. Usually it's kind of a frowned upon behavior, unless in very rare cases, especially for something as common as indexOf, because when you overwrite it, you also, like other folks who are using your code might not know you overwrote something that's like very, very, very standard, and so they might use it under a different context. So that's why in general, like, it's frowned upon to overwrite existing functions. Usually what you want to do is you want to create your own function that copies from the original one and add stuff to it, so you can use your own kind of custom copy without affecting everyone else.
Then you can call it whatever you want, or does it have
Yeah, you can call it whatever you want, yeah. Okay, creating a method. I mean, this is super straightforward, right? So this is just an array. We have our keys, first, last, and rank. We have our values, which in this case are all strings. If we want to add a function to that, boom, we just add a key, right? And the key, once again, by definition, this key has to be a string, because all keys in JavaScript objects are strings, right? And so this is just the name of our function, and the value is going to be this function declaration. This thing here, this line between lines 5 and 7, make sure you're very, very clear, like, on what a function declaration looks like. Like, this is not the kind of thing you kind of like, just like, oh, like, I'll just kind of guess and put a half-baked thing in there and hope that it works, because with regards to, like, declaration and things like that, JavaScript is very, very strict, right? So you're not going to be able to get away with having, extra brackets or extra parentheses or, missing a colon here. Right? Like, this is very, very standard. You need to be able to kind of write that in a very, according to the standard way. But in any case, once again, we add our own key value pair here. The key is just my method, the string. The value is pick whatever we want it to be. In this case, the value is just a function, and it console logs out I'm from a method. So then, if I ever want to call my method, notice how this function doesn't exist independently, right? It doesn't exist by itself. It exists only in the context of this gracehopper object. So if you ever want to call this function, we have to acknowledge that this is a gracehopper method. Say gracehopper dot, and then we name the method, or we call the method, right? And the method, because this is a string, we just call it directly. This is dot notation in this case. We can also use bracket notation too if we want. Usually dot notation is a little bit more like straightforward because once again these have to be strings and they have to match. So if I just do gracehopper the object and we're looking for the my method string or the my method whatever it is, the my method key, we look up the value and we invoke it as a function. In this case, the way that JavaScript actually is going to read it is it's not going to know that this is a function. Bless you. It's actually going to go to gracehopper. It's going to go to the my method key, and whatever value it gets back, it's going to try invoking it. And so if this was not a function, you would get back an error saying, if this is like a number or a string, it would say, this value is not a function or can't be invoked or something along those lines. But yeah.
So we don't need the return keyword when we're calling a function that's inside of an object. We can just say gracehopper dot my method. Like you don't have to say return gracehopper dot my method.
The return keyword is independent of both of those things.
Oh,
The return method is more like if I give you a value, what do you want me to do with it, right? So if I was writing just a function, kind of organically speaking, like whether or not I use gracehopper dot and have return before or after it doesn't really matter.
Right.
Return basically says, hey, this is going to give me back a value, right? What do you want me to do with it? Do you want me to give it back as the next thing, or do I just kind of sit on it, right? In this case, if I look at this function here, the console.log is going to say, it's going to print out I'm from a method, and if the only goal of this function is to say just print something out to the screen, we can kind of assume, okay, we probably don't care the return value because we're not doing anything, we're not giving anything special back. But notice how this function is still returning something, right?
Yeah.
What is it returning?
I'm from a method.
Sorry?
The console log I'm from the string I'm from.
Yep. What is the function returning, guys? If I call my method there on line 5, what is it returning? Yeah. Undefined, right? Every function in JavaScript returns undefined, or returns something, right? If you don't give it a specific value to return, it will always return back undefined. If there's one thing I want to memorize that, because a lot of times what happens is you call a function that returns the return value of another function call, and at some point in the line, if one of your kind of chain breaks, you're going to get back not an error, you're going to get back an undefined. And so that undefined gets passed back all the way back up again. So just always keep in the back of your mind, every function in JavaScript will always return something. By default, it's undefined unless you override that with your own custom return value. So right now, if I just do gracehopper.my method, I console log out I'm from a method. On the other hand, if I put a return in front of line 11 and I execute this line, console log will still console log out I'm from a method, but then right beneath it will be the return value of the function, which will be undefined.
Okay, got it.
Yes.
Could you just quickly show how to use bracket notation to call a method?
Yep, totally. Please be copy and pasteable. Yes. Great. Oof. Okay. Cool. All right. So this is everything so far. Okay. So yep. So this is from the O guy. This is from the O method, and then if I wanted to do bracket notation, I would just simply do yep. Okay. And I'll send out this link too. So, or did I send this out? No, this is a different one.
Will you put something in the parentheses when you are invoking it?
You mean in
If
here?
you put it in there, yeah.
Well, it depends. Is the function expecting to receive anything?
No.
Then there's no point. Right? Like I could put whatever I want inside of
Put it
here.
in there and then what?
I can put like
Yeah.
this thing in there. Well, actually, that's the error because that's not a valid job. But if I put that in there, it's totally
It's
fine.
still, okay.
Because guess what? I'm going to give the function says I'm not expecting
And
anything.
that's
So
just hard to.
yeah, feel free to give it to me. But I'm not doing anything with it. So there's no errors. Yes.
And on line 17, my method before the colon, is that still considered a key with the function being the value?
Yeah, this is always a key. Everything before the left of the colon is always a key. And it's always a string.
Okay.
Right. So here it's almost like we don't put the quotes around it, even though we totally could. It would work the exact same way. We don't put the quotes around it because it's so strictly enforced that every key in JavaScript has to be a string that we kind of get away with not putting it.
Okay.
Although if we want to be really precise, we could put it.
Okay. So if every, so then you never want to start it. Can you include numbers in a key at the end of the name of the key, or you would just not want to put numbers in a key at all?
No, you can put it. You can put it. I mean, what it's basically going to do is, oh, that's because I called this. Like this is totally fine.
Okay.
It's just nope. That's still not right. There you go. That's totally fine, right? Because I mean, you can almost think of it as what JavaScript is doing behind the scenes is when it actually creates that object, it's just basically doing whatever key you give it and is calling toString on it.
Okay.
No, wait. Is it object.toString passing key? Anywho, but this is like it will explicitly convert to a string, and everything I believe in JavaScript can be converted to a string outside of like the nulls and undefineds. So like every number can be converted to a string, booleans can be converted to a string, like these things. So yeah, so it's kind of like a very nicely enforced convention. Okay. So yeah, so now we're done calling methods, or now we're done creating our own methods on the object, and we're done calling it to, or we're able to call it, and then this is just saying that usually, and this kind of goes for everything, just kind of the rule of thumb, you want your key to be somewhat descriptive of your function, right? You don't want to just call everything foo and bar. You want to say like, in this case, say quote or something like that, right? So the previous example of calling a key my method is not super helpful, right? But for say quote, maybe it's a little bit more nomenclature, right? This is more like, I remember the first day we did like variable naming, just better variable naming. It's kind of more like along those lines. Yeah, like it won't break the JavaScript, but like it definitely makes it hard to use for future users of your object. Okay. So then, kind of fixing that, we can have as many key value pairs as we want. So therefore, we can have as many functions as we want attached to an object. There's, realistically speaking, no cap. Objects, computer memories, like those are going to be your like cap, but like there's, you're not going to reach it. Like assuming you use JavaScript normally. So in this case, we have two keys. One's called say quote, a string. One's called get age, also a string. Their values are both functions. And notice how, I guess to your earlier point here, this function takes in nothing and just comes along out. This guy actually takes in a value called year, and it returns the year minus 1906. And so if we ever do call get age as a function, we actually need to pass in an actual number, because once again, this function is expecting a number. What happens if we don't pass anything here? What if this is blank? What if we just call get age, open and close parentheses? Not a number? Okay. Anything else? Undefined?
1906.
I'm sorry?
Minus 1906.
Negative 1906? Okay, cool. Yeah, I guess you get back not a number.
If it was a plus sign, it would be undefined 1902, because it will concatenate to the string. If it was year plus 19.
I don't know if that makes a difference because
Undefined string concatenated with the year.
so here we get back. Oh God, what did I do? Did I forget to delete something?
There's one of those question marks right there after the line.
No, that's fine. That's a string value. No, I think what happened is I defined grace hopper twice. Here. So I'll call this grace hopper 2. I'll call this grace hopper 2. Great. Okay, so therefore that works. And just so you all know, like the reason why the error was coming through was because the let keyword is also kind of, once you create something with let, it won't let you create another one called let as well. It's saying, hey, like either you're going to create a new variable or you're going to use the one that exists in just override it. You can't just use let kind of too liberally by creating the same thing over and over again. So that was why I got the error last time. Okay, so if the question was if I do this now, I get back not a number. Great. Sure. Yeah, this should also get back not a number as well. And the reason why is because if I don't pass anything in, what's the value of year at this point? I hear different answers, which is great. Right, year is undefined. Year is undefined because, once again, right, here what this function is really saying is, hey, we have this variable, you didn't give me a value, I know it exists, so therefore it's undefined, right? Like, it's like this value, I'm not saying it's null because you didn't tell me it's null. I can't say it's a number or a boolean or anything because you didn't tell me any value, but I know the variable, like, quote unquote, exists, right? So by default, it's undefined. And so here, when we did line 30, 36, what we're really saying is undefined plus a number. And usually in that case, what that means is, so one, it's not going to do a concatenation because neither one of those are neither one of the two parts are strings. So definitely won't be a concatenation. It'll probably default to like the data type that is more like real, if you will, like the number. I will say, great, what's 1906 plus undefined? Well, it's not a number, right? Like one of those things is not a number, so the other one must not be a number. Yep.
So is it normally you just see options with like more functions in them, right? Not just like would you create an object that's full of function that you want to invoke throughout a series of code per se, like, and then put them on the series of code?
I mean, you create objects to store whatever you want.
Store whatever you want.
Usually, like, so it really depends, right? Like, objects kind of have two. If an object is too complicated, usually it's a good rule of thumb that it should be made to a class. And once again, I don't want to talk too much about classes, but even with objects, like when you look at it, it should be very clear what the purpose of the object is, right? It should just be kind of this infinitely long thing and keep adding to for no reason. Eventually, you want to migrate to a class and it gets too complicated. In most cases, objects are kind of more just convenient ways to host information with a few simpler methods. So yeah, but I mean, like, look, like, ultimately, like, there's no like hard or fast rule about how many functions you have on an object. Feel free to do whatever you want as long as you understand kind of how it's working behind the scenes. But once again, right, if you're creating an object that's really, really long, or more importantly, if you're creating the same object over and over again, which we'll see in a little bit, that's a good indication that you should be migrating into a class instead of keeping it as a vanilla object. Okay, cool. So this part hopefully makes sense now, but once again, this is a full function, so we can also have inputs as well, or arguments being fed in as well. And then lastly, this is another example, except what this is trying to show you is, hey, if I want to console log out my name and say hi, name, so, like, let's say I'm saying greet David, right? I pass in David as to the greet function. I say, hi, David, I am Rear Admiral Hopper. And that's cool. The only thing here that's a little bit less efficient is, well, I'm kind of writing Rear Admiral Hopper when theoretically that those values already exist, right? So it'd be really cool in JavaScript, or sorry, in programming, there's this like acronym called DRY, don't repeat yourself. So if someone says keep your code dry, it just means, hey, you're writing the same code over and over and over again. Maybe try making it a function so you can reuse it in different instances without writing the same thing over and over again. So in this case, this is slightly not dry because we're typing in Rear Admiral Hopper when in reality those already exist as values on our object. So, so one quick way to get around that is to actually do something like this now. Say console.log out, hi, I am, and then we can do gracehopper.rank, comma, gracehopper.last, right? And this will get us to the same exact output of, in this case, hi Gabe, I am Rear Admiral Hopper. And so now we're actually using the object values. And the really cool part of this is cool. I use the term loosely. If Grace Hopper somehow got promoted, right, and she's no longer a Rear Admiral, let's say she's a captain, right? Well, then I need to change her rank, but I need to go inside and manually change her rank here as well, right? But if I just use her rank directly from her rank property, now if I change this to captain, this automatically kind of follows suit, right? So it's also a really good way and so this is also a really good way for you to kind of make sure like the values that should be in sync are all coming from the same exact place. So if I want to change it, I just gotta change it once, rather than running around and changing it in like 2 or 3 or more different locations, because once again, it just makes the code hard to use. Does this make sense, everyone?
I have a question.
Yes.
Just wondering if it follows the same
Sorry, what?
like control flow we've been learning, but if you made the argument name, if one of the keys was named,
Yep.
and then you put in the argument name,
Okay.
where would it would go to the name, the key, right, rather than
Well,
rather
no,
than,
because
like, the argument.
so this function has its own little
Oh,
scope,
yeah,
right? So this name value is going to be whatever is being passed to the
In
function
name,
first.
Okay.
And in fact, this will never read anything outside of this scope, because it's going to say, I expect a name variable, and if you don't give me any, I'm just going to assume you've been undefined.
Okay.
It's not going to look elsewhere for it, right? If we don't have the name inside this parentheses, but we put it inside this code, then it'll say, oh, let me look for it in my own scope. Let's look for it like in my parent scope, grandparent scope, etc. But because it expects the name to be passed in and created on the first line, it will either create it. It will definitely create it. It'll just either be a real value or be undefined if you don't give it a value.
Okay.
Okay, cool. So if this makes sense, then the last thing we'll talk about today is something called this. It's incredibly hard for me to verbally explain, because obviously colloquially it's just this sneaks in a lot of different places. But this is a reserved word in JavaScript, THIS. If you type it in your JavaScript editor, it will probably show up in a different color than the rest of the text, right? So it's kind of like for or return. Like you can't override this. You could, but you don't want to. Okay. What this does is, in the context of having an object method, when we use this inside the method, what this refers to is the object that this method is being tied to. So here in the previous example, we were doing gracehopper.rank, right? And then gracehopper.last. Well, if I know that this is a reference to the object I'm tied to, I'm looking for the rank and the last, I can actually just do this.rank and then this.last. It saves me a little bit of time, and this is a part that's a little bit kind of even a little bit more trickier to see unless you've seen kind of code work in real environments. The reason why this using Grace Hopper is also not as effective is because for this code here, for the code that I have written here, this Grace Hopper is hard coded, right? This only works for this object called Grace Hopper. As in, I can't use this greet function anywhere else. Because if I do use it anywhere else, it will always greet based on Grace Hopper's rank and Grace Hopper's last, right? On the other hand, if I use this, then this is it will dynamically say, hey, what object am I on? And let me use that object's rank and that object's last. So if I create Grace Hopper, this is going to refer to Grace Hopper still. If I create Grace Hopper 2, well, then this becomes a reference to the Grace Hopper 2 object, right? And so once again, we're kind of at every step of the way, we're just making our code a little bit more flexible so that we can use it in different contexts without having to go in and manually change anything. So in the first example, we were just hard coding everything, right? I am rear admiral hopper, and that's like super inefficient. So we say, great, let's just read the values from the objects. Except we were only reading the values from that one object. Now, by transitioning over to this, we're able to read it from the object that this function is attached to. But this also means, hey, this could work for any object we put this on, right? And so one thing that one way to think about this is, let me just do a quick example here. Okay, so let's say I have. So let me just comment out all of this. And comment out all of this too. Okay, great. So I have this little fella here, and then I do this. Okay, so this is still perfect. This works perfectly fine, right? The point I was making is, what if I had something that does? So I'll have a function called David. Function David. Okay. Cool. And then for greet, the value is just going to be David. Everyone good so far? when I run this code, nothing changes, right? I've created a function called David, says hi. Everything's like still like really kind of up to snuff. But if I have another variable and I call it gracehopper2, and rather than having rear admiral, let's say this is their cat, so we'll say captain, and then this is this captain, and we'll call this full stack. And I do gracehopper2 dot greet Kate. Notice how I didn't have to change my David function at all, right? And instead, I'm able to greet two different people, right? When I call it up here, when I do gracehopper.greet, it's saying, okay, greet Kate as if you were the Grace Hopper object, so rear admiral hopper, right? When I called it for the Grace Hopper 2 object, it says greet Kate as if you were Grace Hopper 2, right? Because this greet function is from David, and the David function reads from this dot rank and this dot last. This for this first line comes from the Grace Hopper, right? So this dot rank is rear admiral, and this dot last is hopper. On the second line, this dot rank and this dot last comes from Grace Hopper 2, and so it says, "Hi Kate, I am Captain Fullstack." And so this is like kind of one intro example as to why we often really want references to this, is because hey, I can use this David function now on any object I want. I don't need to change to say Grace Hopper dot rank, or to change it to Grace Hopper 2 dot rank. I just use this dot rank, and now no matter where I use this function, it's always smart enough to realize, oh yeah, like I should be pulling from the object that I'm currently attached to, as opposed to pulling from one single source the entire time. Make sense? Yes? Yeah, totally.
The scope is not what we expect, is kind of the thing.
I'm sorry?
So the scope is not what we expect.
Uh,
It seems like we're able to reference, first we have David, and then it looks for like what the David function is going back up.
yeah, so
So this is all within one function. Okay, yeah.
So the tricky part with this is that as you can probably kind of start inferring at this point, right? This is not constant, right? It's almost like in English when I say like this house, right? It depends on which house I'm literally in at that moment, right? If I say I'm on, like, it's almost like someone calls like, where are you? And you say this floor, it's almost useless because you're like, well, if you're on the 11th floor, this floor is 11. If you're on the 25th floor, this floor is 25, right? And so just kind of keep in mind that this is not like a fixed value, right? Instead, this is being determined based on the object in which this function is being used right now. And so when we do this inside the Grace Hopper object, this refers to Grace Hopper. When we do this inside the Grace Hopper 2 object, this is Grace Hopper 2. And so that's why like the scope is what you expect. Like, it's just like the way we've been trained to expect scope is it doesn't necessarily hold completely true in this case. And then Jeremy, your question was to explain that all over again?
Yeah.
Okay. I guess like yeah, I guess like the main crux here is, in this case, for Grace Hopper and also Grace Hopper 2, we both have a function called greet, right? And the function is both this function called David in both cases. The question now becomes, when I do Grace Hopper.greet and Grace Hopper 2.greet, how does it know to read my last and my rank from different objects, right? I'm sorry? Right. So if you remember in the first example that we did here, let me just yeah, okay, great. Remember how in the first example here, we did something literally that was kind of almost very stupid in retrospect, which was I am reared admiral hopper. Like we literally wrote that as a hard-coded function, right? And when we did that, it's basically what that means is no matter who is using this function, whether it be Grace Hopper or Grace Hopper 2, we are literally saying the same exact thing every time. And for one of them, it's not true, right? So that's like a no-go. On the other hand, if we change that to oh god, if we change that to say, all right, let's just make this Grace Hopper dot rank and then Grace Hopper dot last. Well, this is really cool, assuming I'm only calling it from the perspective of Grace Hopper, right? Because this function is built, hard-coded, basically to only read everything from Grace Hopper. So when Grace Hopper calls it, right, Grace Hopper 2, and then using a different.
Just to be clear, the function David really doesn't have anything to do in this case with the Greek David, the Greek value David.
These two are the same thing.
Why do we need that? Like, I mean, but it doesn't influence, without the Greek David, you still get the same IK not mirror admiral hopper, right?
Without the Greek David?
Yeah.
Not really.
You
Don't
wouldn't
you
get
have
the
to?
rank or the last name.
As in you're saying if we delete this line right here?
Yeah, what happens?
Well, now when we call gracehopper.greet, it will say there's no greet function on the gracehopper object.
Oh.
Right?
Weird. Okay.
Right? Like this is basically saying, okay, I'm trying to invoke this greet function, and I'm going to acknowledge that the greet function is attached to this gracehopper object.
Oh.
And it'll say, great, let's go to gracehopper, awesome, give me your greet key. Say, I have no greet key. And it'll try invoking and throw an error, say undefined is not invocable as a function or something along those lines. Right?
Okay.
So we most definitely need this greet colon David.
Oh, I see. Okay. But what if we had gracehopper.david?
It would look for the David key on gracehopper, and that David key also would not exist.
Okay.
Right? Well, I think the way to get around this in your example here is we actually can't call gracehopper.anything, right? We actually just call David by itself,
I see.
right? So we just do David, insert, and then Alex, and that should work.
Right. Okay. Cool.
And so David is a function here, greet is a method here, right? Because this is tied to the gracehopper object, whereas David is not tied to anything. It's just a free-floating function. Yes.
So if you use the David function in another file, are you going to be able to access it?
That's a little bit of a more complex question because it depends on what's loaded on the page. Usually in most websites, what they do is they kind of load everything onto the same page, and at that point you have access to a bunch of different things, and that's really great. In other environments, they may say, they may load up the page one at a time, in which case you wouldn't have things loaded on other pages. So it really depends upon the order in which you're loading things, and that varies depending on the environment quite drastically. Cool. That's pretty much it. So this is why this is ultimately our preferred vehicle of choice, because we can use this as flexibly as possible, right? We can use it to refer to any object really, as long as it's being called from the right origin point. And then this is just to show that and this is probably going more to your point, Alex, of the return statement. All of this is independent of return. Return is still just, am I giving you back a value? If so, what am I giving it back to, and who am I giving it back to? And so in this case, we have this function. All we do is return this. And so when we call gracehopper.get this is going to return this, and we're going to capture the value of this in this return object variable, right? So this whole setup exists independently of the return value. But return is also very critical, and if you don't understand, so I guess the two things are, when you start this workshop, if you're not clear on how return works, or if you're not clear on how function declarations work, spend a good 15, 20, 30 minutes on just that part, because if you don't have a good grasp of that, you're not going to be able to really understand how the rest of this works, right? And the return is probably one of the most critical things that you'll need to understand as a developer. I guarantee you on the interview, your interviewer will ask you about return statements, because it is one of the things that people who are starting off, they were I'll just make everything a console log and not think about it, right? When in reality, that's console logs are actually a lot less useless and they're a lot more useless in the real world, because you don't care about what it prints on the screen. You want to care about what values are being actually used or passed back and forth between functions. So brush up on this and brush up on returns. Brush up on function declarations and brush up on return values if you're still unclear about either of those two things. Yeah, Hubert?
What would they ask you about?
They will probably not ask you explicitly. They'll probably have you call a function, write two functions, and when you call one function, it passes the value to the other function, and that will test if you know how returns work. Because if you don't return the right value from the first function, you're not going to be able to ingest it to the second function.
So here we're just returning this.
Yep.
Like letter of okay. Just
And what is this? Which object?
Grace Hopper.
Right. This is a Grace Hopper object. Did you already do that? Actually, no. We'll talk this tomorrow. Actually, object comparisons. Yeah, we'll talk about tomorrow. Okay, cool. All right. So last slide. Just a quick, simple example of an object. We have a sum function. We have a difference function, and in this case, we're just returning this on num1 plus this on num plus this on num2, and the difference obviously is a converse of that. We have a sum and a difference key. These two are both functions. We're returning a value, yes, but in both cases we're reading from the object directly. So this probably puts together everything that we've ever talked about today, kind of in one clear object example. And the last thing I want to show you here is this notion that, hey, guess what? When I calculate this on num1, I am literally fetching the object's value at that point in time. And so how we show this is because up here when we do calc.sum, we're doing num1 plus num2. What's 20 plus 30? It's 50. So we print it out. Right? What's the difference of this on num1 minus this on num2? Well, it's 20 minus 30, so we should be getting back negative 10, right? But notice how we do line 12. On line 13, we actually changed num2 to 15. So now when we calculate calc.difference on line 14, we're actually doing this. Num1 is still 20, but num2 is now 15, right? So once again, whenever we run this function, we are literally fetching the value of the object at that point in time. It's not like a historical value, it is at that point in time. So once again, if we change any of these key value pairs, it does affect the function when it reads this. It picks it up from the object at that point in time. Yes?
This is a little silly, but there would be another squiggly bracket after the calc.num2 change, or is that outside of the brackets?
Another squiggly bracket.
Basically, is that calc num change inside the function or outside the function?
It's not inside any function.
It's not inside.
We're just literally on the page, we're just running code.
So that let calc is what kind of statement? It's just like a variable definition?
Well, so calc is an object, right? We're saying we're creating a variable called calc, and the value of it is this object. And so here we're just going and saying, hey, this object key, or this object's key, change the value for that key from whatever it was to 15.
Does that have to be in the initial object definition, or no? It can be outside?
Well, clearly it's not, right? Clearly, this whole point is we can create an object, and then we can change it afterwards. Right? Like if we had to define, in your example, I guess if we could only do it once, then this would not run, right? Because clearly we're defining calc, we're running something on calc, but then we're changing calc again and running it again. And so this is, and yeah, calc or objects are meant to be changed almost, if anything. There's a reason why they're the things that are not changeable are the primitives, like the strings and the numbers and such. For arrays and objects, usually you use those for the purpose of future change flexibility. So in this case, we definitely are able to change calc, and calc is once again not part of any function because we're literally just changing a value for an object. Cool. All right. So the last thing we'll say is just a bunch of this is an incredibly complex topic. In that sense, I don't even know a lot of the nuances with this. So don't think it's just what we talk about today in class. This is a really it's a really critical part of this concept of inheritance in programming. And so take it for what it's worth for now for this lesson. Just know that we're touching a very small corner of it. There's a lot more to this. Cool. So that was pretty much it. Any questions?